I'm Kara McDaniel, one of your professors for Econ 211, and this is our live review broadcast. I'm sorry that we have to do it again. The last one failed due to technical difficulties. Actually, I should say operator error, operator being me. But we're going to try to do the same material in this review that I did last time. So I'm going to review for a while, and if possible, Professor Fernando will join us later on, but if not, it'll just be me. So I want to answer some questions that were posted about quiz questions, or questions like the questions that were posted about quiz questions in weeks 2 and 3. So what we have here is we have an indifference curve. And this is an indifference curve that our consumer, let's say it's consumer Kara, that'll be me, indifference curve reflecting how our consumer feels about apples and pears. So here I've plotted the quantity of apples on this axis and the quantity of pears on this axis. Now, consumer Kara ultimately will, the first question, will consumer Kara ever be satisfied? And the answer is no. Consumer Kara will never be satisfied because she would always like to be on indifference curve. This is just one indifference curve, of which there are many, 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 many indifference curves, and each indifference curve on a higher level represents a higher level of satisfaction or happiness or utility. Consumer Kara is happier out here than she is here, happier out here than here, and happier here on indifference curve 1 than anywhere below. Looking at this picture, we can't tell if apples and pears are substitutes or complements. We can't tell if they're normal or inferior goods. We can't find her optimal consumption bundle because we don't have any information about prices or her budget. All we know is that every point along this curve provides consumer Kara with the same amount of happy or utility. So we can look at this indifference curve and say something about the trades that our consumer would be willing to accept. Let me erase these here. And let's say that consumer Kara has 5 apples and 5 pears. And we asked consumer Kara if she would be willing to forego 2 apples in exchange for 2 pears. So what we would need to do is say, okay, what happens to consumer Kara if we reduce her consumption of apples by 2? That gives us a consumption bundle of 3 apples. And in exchange, she can have 2 pears. 2 more pears. So she has a consumption bundle of 3 apples and 7 pears. This is our new consumption bundle after we offer her a trade of 2 apples for 2 pears. So question. Will Kara trade 2 apples for 2 pears? If she does, she'll be on consumption bundle 3-7, and that looks to me like a point on a lower indifference curve. So the answer to that question is no. We don't know the price of apples, the price of pears, income doesn't matter. All we know is if she has this consumption bundle, she won't trade to get her this one. So this is one of the useful pieces of information that our indifference curve provides us. Next, let's think about, would consumer Kara trade 3 pears for 5 apples? And if we're at 5, and we say reduce your consumption by 3 pears, that goes from 5 to 2, and in exchange receive 5 apples, go from 5 to 10, that puts her at this point here. This is not coincidental that it's on the same indifference curve. Would she accept that trade? If it was costless, she would, because consumer Kara doesn't actually care about the difference between 5 and 5 apples and 5 pears, and 10 apples and 2 pears, because they're on the same indifference curve. So this brings us to one of the concepts that you discussed in week 2, which is along this indifference curve, this is our rate of substitution. She would be willing to forego 3 pears in exchange for 5 apples. Now that's her rate of substitution from here to here, but we also know that that rate of substitution is not going to be constant along her indifference curve. If we were to take away more pears from her, we have to give her more and more and more apples to keep her just as happy as she was before, because we could continue our indifference curve all the way around here. So our rate of substitution is not constant along this indifference curve. Now, just to recap about the trades that consumer Kara would accept, consumer Kara will accept any trade that keeps her along this indifference curve or would put her on a higher indifference curve. Consumer Kara will reject any trades that put her on a lower indifference curve. So would she trade, say, 2 pears for 6 apples? Yes. Anything that would put her out here. Another thing that we showed is our rate of substitution is not constant along an indifference curve. And if she has a lot of pears and very few apples, she will accept a small amount of apples in exchange for giving up a larger amount of pears, and that becomes less true as we move along the indifference curve. As we take away more and more pears, we have to compensate her with more and more apples to keep her just as indifferent, just as happy or indifferent. All right, so we have looked at an indifference curve and talked about the trades that our consumer will accept. We've talked about the rate of substitution and how it changes along an indifference curve. So what we're going to do next is we are going to show how consumer Kara will maximize her utility and select her optimal consumption bundle if we give her prices for apples, prices for pears, and a certain level of income. So let's do that. So to help us, I'm going to clean this up a little. I'm going to make this indifference curve 1, and I'm going to draw in a few more indifference curves, understanding that consumer Kara, I'm going to try to be careful here, consumer Kara would like to be on the highest possible indifference curve. But we need to give consumer Kara some income. So let's give consumer Kara income, and we used M for income in this class. Let's give her $10. And we're going to make our notation easier, we're going to say apples, we're going to call that our X1 good, and pears X2. This is what Professor Fernando does. All right, so let's give her income of $10, and we're going to say that the price of apples is $1 per unit of apples, and the price of pears is $1 per unit of pears. All right, so we need to plot her budget constraint, and I'm going to plot budget constraint green. All right, if consumer Kara spends all of her $10 on the purchase of apples, she's going to be able to consume 10 apples. So in her budget set, we have 0 pears and 10 apples. And if we wanted to, we could make a table that tells us what's on her budget line or on her budget constraint. And so if she consumes 10 apples, that takes all of her income, she's not going to be able to consume any pears. So 10 and 0. Now, if she instead decides to, let's pick another point arbitrarily, let's say she wants 7 apples. Those 7 apples will cost her $7. That will leave her $3 left, and she can have 3 pears. So 7 and 3 is also on her budget line. This is going to be linear, like all the budget constraints that you've seen in this class. So it's pretty easy to see the points that will be on our budget line. So let's draw in our budget constraint. Okay, not too bad. There we go. Now, given the preferences that we have identified for consumer Kara, what feasible consumption bundle maximizes her utility? Well, we know that consumer Kara will maximize her budget. More is always better, so she's going to choose a point somewhere along this green budget line. She can afford this point, she can afford this point, she can afford this point, this point, this point, but which of those points gives her the highest level of utility? It's this one right here. She cannot do any better given the price of apples and the price of pears. So it's this point here that maximizes her utility. Now here's another question that we had. At this point, is consumer Kara completely satisfied? The answer is no. Consumer Kara will never be completely satisfied. Consumer Kara always wants to consume on a higher indifference curve. She wouldn't be completely satisfied here. She won't be completely satisfied up here. Even if I went all the way to the top of the wall right here, consumer Kara is still not going to be completely satisfied. So this maximizes her utility subject to her budget constraint, but will never satisfy. That's just something you should be careful with. Well, let's look here. What is the approximate rate of substitution at the optimal consumption bundle? Well, approximately, it looks like it's close. It's not quite. It's close to 1 for 1. The rate of substitution, we have to make this really small, but if we made it closer and closer and shrunk it up without using calculus, the marginal rate of substitution at Consumer Care's optimal consumption bundle is about -1. That's also the slope of the budget line. It's also the relative price of pears in terms of apples. So how many pears does one apple cost? 1. 1 to 1. Now let's change that. Let's suppose the price of apples rises. Suppose the price of apples rises and is now $2. Our price of apples rises to $2. Now, this, I'm going to clean this up here so we can do a better job. I'm going to need to sketch in another indifference curve, so I'll try to leave this one. No, I'm going to get rid of it. Clean it up. Okay. Now, can Consumer Care purchase 10 apples? No, she can't. Can she purchase 7 apples? No, that's $14. Her income hasn't changed. It's still $10. So this isn't possible anymore either. Now, none of these are going to be relevant anymore. But can Consumer Care afford 5 apples? Yes, she can, because if she pays 5 apples and they cost $2 per apple, her total budget is $10. And that's costs all she's got, so she can have 5 apples and 0 pears. If she chooses to have 3 apples cost $6. That leaves her $4, and she can spend the rest of those $4 on pears. And each pear costs $1, so she can have 3 apples and 4 pears. Or she can have, she wants to spend all of her income on pears. They cost $1 each. She still can afford 10 pears. So this point right here is still on her budget line. Now let's connect these dots here. Actually, that doesn't look very good, does it? That's a little bit better. There we go. There is our new budget line. This point is no longer feasible for Consumer Care. What has happened to the price of an apple in terms of pears? The relative price of an apple. The relative price of an apple has increased from 1 to 2. Or 1 apple now costs Consumer Care 2 pears. Now, we don't know what she's going to do yet. We need to draw, we can't use calculus. We don't have a utility function. We can't write down a maximization problem and solve it that way. That's what you would do in intermediate. but we can use our picture. But we know with 100% certainty, Consumer Cara is not happy about this change. So we are going to see, what does Consumer Cara do? So what you might do in a principles class is we're going to use this indifference curve as a guide, and we're going to try, even though we know she can't afford to consume on this indifference curve, we're going to try to find the best she can do. And it looks to me like we're pretty close at about right here. Okay. So our new indifference curve right here looks a lot like the other one. Oh, isn't gonna go. Should only be touching right here, but we get the idea. Our new optimal consumption bundle is 3 apples and 6 pears. And what has happened to the rate of substitution between apples and pears? It's changed. Now, instead of 1 to 1, like it was along this budget line, it's now -2. So at this point right here, marginal rate of substitution is equal to the relative price of apples and pears, which is 2. Okay, so we know that Consumer Cara is not as happy as she was before. The law of demand tells us that in response to an increase in price, it must be the case that Consumer Cara reduces her consumption of apples. So we know, here's her old consumption bundle, here's her new consumption bundle. She has reduced her consumption of apples from 5 to 3. Now, but what about her consumption of pears? What she does is going to tell us about the relationship between apples and pears. Consumer Cara used to consume 5 pears, and as a result of an increase in the price of apples from 1 to 2, she increases her consumption of pears. That makes apples and pears substitutes. In response to an increase of price of apples, Consumer Cara increases her consumption of pears. Here we go. All right, so the next thing that we're going to do is we are going to derive a demand curve for apples. So we're going to, we changed the price of apples. So let's start out by plotting. I'll just plot it right here, see if we can fit here. How far over do we go? And we can fit it right here. So here we'll put price of apples. And here we have quantity of apples. And we have price of apples and quantity of apples. We started out with, we had, let's make this $1. Let's make this $2. Let's make this $3. And we are going to plot the 2 points that we have. So in this mess that we've made right here, which I'll tidy up a little. We have 2 points. Actually, this looks more like 2.5 than 3 to me. So we've got 2.5 and 6. And then here we have 5 and 5. So in response to an increase in the price of apples, Consumer Care reduced her consumption from 5 to 2.5. But first, let's plot 5 and $1. So this is 1 point on Consumer Care's demand curve. If we increase the price of apples to $2, Consumer Care reduced her consumption of apples to 2.5, right about here. Plot that right here. We have a second point. And then just because we want to be extra thorough, let us increase the price of apples to $3. Let's increase the price of apples to $3. So let's say, where's my black pen here? Oh, here it is on the floor. Let's increase the price of apples and she can't consume 5 anymore. What's the maximum number of apples that she can consume? Well, that is 10 1/3. So that's 3 1/3 apples. That's about right here. So she can have 3 1/3 apples, even though she may not choose 1/3 of an apple, it's still in her set. So we'll put that right here. And if she chooses to have, she can't have this anymore. She chooses 3 apples. That leaves her $1, and she can have 1 pear. So 3 and 1. And if she chooses to have 0 apples, she can still afford 10 pears. So we are going to sketch in our budget line right here. So this is 3.33, and there's our budget line. And we're going to have to kind of make some guesses about, go this way. I think that's looking easier. It looks to me like she's going to be somewhere up here, where she's going to have 7 pears and 1 apple. So if the price of apples is $3, it looks like Consumer Care is only going to consume 1. Well, we have 3 points on the demand curve here. Let's just roughly fill these in. We call it a demand curve. Most of the ones that we show you in this class are straight lines, or they're linear. And this one's got a little curve to it, but it doesn't really matter because we're only talking about, directions of change. And we can roughly estimate with a linear demand curve. All right, so now we have plotted a demand curve. Well, it obeys the law of demand. Now, what a mess over here. So let's clean this up and go back to our old case where prices were 1 and 1. So if she was choosing to have 1 apple, spending $3 on apples and 7 pears, that's still consistent with apples and pears being substitutes. So let's think about what might cause this demand curve to shift. So what would cause, other than a change in the price of apples, which generates a movement along the demand curve, what other than a change in the price of apples would change this consumption bundle? Well, we can change 2 other things. We can change her income, or the price of pears. Those are the only two choices that we have here, because this is based on our very, very simple economic model. So let's change our income. Should we increase or decrease our income? Let's find out if they're normal goods, and let's increase Consumer Cara's income to, let's increase her income to $12. Increasing Consumer Cara's income to $12 is going to shift her budget line to the right, and it's going to keep the slope of that budget line constant. We're going to return to the case where the price of apples and the price of pears are both 1. So if she wants to spend all of her money on apples, she could have 12 apples. And if she wants to spend all of her money on pears, she can have 12 pears. And that's pretty much off the screen there. So we will sketch in our budget line that's parallel to the other one. That's close enough. And what can we see automatically? Well, Consumer Cara is going to be happier, right? Because she could potentially have more of both goods. And we remember that one of the assumptions we made when we were talking about indifference curves and utility is more is always better. So an increase in income is automatically going to make Consumer Cara happier because she could potentially have more of both goods. But maybe if a good is inferior, she doesn't always choose more of both goods. But in this case, we can figure it out by, just like we did before, sketching in indifference curves that are similar to what we had before. All right. All right, let's make sure these add up. So 7, looks like she can't afford that, because that's costing more than her income. I put her on too high of an indifference curve here. I think I drew my budget constraint a little too far out. I'm going to have to redo that here. What we do for live review sessions. There we go. That's a little bit better. Drawing. That didn't quite make it. Didn't quite make it. Ha! All right, here we've got a point. Looks like we had 6 and 6. All right, she can afford 6 and 6. 6 apples cost $6. 6 pears cost $6. Her income is 12. That uses all of her income. And if the price is $1, she consumes 6 apples. And that puts her out here. Now, with a higher income, she's no longer on this old demand curve. It's because this demand curve is no longer relevant, because along this demand curve, her income was constant and the price of pears was constant. So Consumer Cara has a new demand curve. And we could do the same thing. We could say, let's suppose the price of apples rises. And if the price of apples rises to $2, her budget set shrinks, and we have to find her new optimal point. And we would find the new optimal point. And with this higher level of income, it would be less than she would consume if the price of apples were $1, but more than if she had only $10 in income. And we can just guess where that is by keeping the slope of this demand curve the same and shifting it to the right. Now, if we wanted to, we could say, what would happen if we, instead of increasing the price of apples, increased the price of pears? And apples and pears are substitutes. So we're not going to go through this exercise again, shifting budget constraints, finding the optimal point on the indifference curve where the marginal rate of substitution is equal to the relative prices. But you know that apples and pears are substitutes. So let's suppose the price of pears falls. Let's suppose pears get cheaper. If Consumer Cara views apples and pears as substitutes and the price and pears get cheaper, at every possible price of apples, Consumer Cara is going to choose fewer of them. And she's going to do that because the rate of substitution will change because the market rate of substitution will change. So pears become cheaper. Consumer Cara is going to choose to consume more pears and then also fewer apples because these two goods are substitutes, and her demand curve will shift left. Okay, well that's we've gone through quite a bit of our consumer choice theory. We've talked about indifference curves. We put in a budget constraint. We found the optimal consumption bundle. We've shown how that consumption bundle changes in response to a change in the price of apples. We've derived a demand curve. We've shifted the demand curve in response to a change in income. We have hypothesized about what direction it should change if we change the price of pears. We've already verified that apples and pears are substitutes, so a fall in the price of pears should lead to a reduction in demand for apples. Let's do one more thing. Let's calculate elasticity along this demand curve. So I'm going to erase this over here because we're done. And let's erase this demand curve and this demand curve and just look at these points here. This is 2.5 and 5. So let's find the elasticity of demand along this area of the demand curve. So let's recall that elasticity is the percent change in quantity demanded in response to some percent change in price. And we can rewrite this as the absolute change in quantity divided by our initial quantity divided by the absolute change in price divided by our initial price. Now, let's calculate the elasticity of demand here. So our change in quantity was an increase. Okay, first, let's stop getting ahead of myself here. Let's stop and think about what happens if we go from here to here. The price of apples falls from $3 to $2. And in response, there is a change in quantity from 1 apple to 2.5 apples. So the absolute change in quantity in this case was 1.5. Or let's say that's because we're going to end up canceling some stuff. Okay, and our initial quantity was 1. Okay, that looks like it'll make our lives easier here. Now, what happened to price? Well, the absolute change in price was from $3 to $2, so that was $1. And the initial price was $3. Now, the nice thing about elasticity, it doesn't matter if we're pricing these in terms of dollars or in terms of euros or in terms of anything else, because our dollars cancel out. So what we have is an elasticity of 3/2. That goes away. Oh, and I dropped a negative sign. There it is right there. So our price elasticity of demand is 9/2 or negative 4.5. Elasticity is negative 4.5. Now, what's important to notice here is that's the price elasticity of demand if the price falls from $3 to $2, or if the price rises from $2 to $3. But it's not going to be the same if we change the price from $2 to $1. So let's go the other way. I like to do price increases as well. So let's suppose the price increases from $1 to $2. So I'm going to erase this part right here. And suppose pricing increases from $1 to $2. Then we see that our quantity decreases from 5 apples to 2.5. So our absolute change in quantity is 2.5. So 2.5. Actually, I like absolute change in quantity. 2.5 is 5/2. Just in case you're missing out there. So that's our absolute change in quantity divided by our initial quantity, which was 5. And our change in price, we decreased. We went from $1 to $2. So our absolute change in price was $1. And we started out at $1. So this is easy. That cancels out. That's just 1. And then what we have here is negative 5/2 divided by 5, which is negative 1/2. So what did we see? As we move along our demand curve here, our price elasticity of demand has changed, and a percent increase a 50% decrease, which is negative 1/2. Yeah, that's right. This is the beauty of live review session here. As we move along our demand curve, elasticity changes. It's very elastic up here, where a small change in price is going to lead to a large increase in quantity in percentage terms, to down here, where a small change in price is going to lead to even a smaller change in quantity in percentage terms. So in this example here, we've run through pretty much our topics in consumer theory and consumer choice. And this is a key part of principles of microeconomics. And one of the ways that we have decided to teach this class is normally in microeconomic principles, you'll get introduced to the demand curve and the determinants of demand curve first, before you talk about utility and indifference curves and substitution. And we felt as the professors of this course, that it made a lot more sense to introduce you to what many professors view to be challenging concepts of budget constraints and indifference curves and optimization, so you understand where this demand curve comes from. And then, once you understand where this demand curve comes from, thinking about movements along the demand curve and shifts in the demand curve are a lot easier because it's not something that comes from nowhere. Now, some of the questions about economics and microeconomics is that we needed to make some assumptions when we solve these problems. We need to assume that consumers can see prices, they know what their income levels are going to be, they have access to the goods and services they're trying to purchase, and we know that, and that they behave rationally. We know that real life is more complicated, and to understand maybe the decisions of our complicated consumers in real life, it's very important that we understand the decisions of consumers in a simplified reality, and then we could modify our model later on to make it more complicated. But sometimes, and actually very often, these simple solutions are very powerful and they can explain a lot. So we've had some questions about how the intersection of economics and politics. And one of the things that becomes obvious as you continue to study economics is there is a huge intersection between economics and politics. Any policy that changes the trade-off between two different goods or might change their market prices is going to be relevant in economics. So let's suppose that we have an economy where apples are imported. And maybe to protect the producers of domestic apples, we slap a tariff on the import of apples. That's going to change the relative price of apples and pears. That's going to change the behavior of our consumer. It's going to change the market price of apples. Maybe usually tariffs result in an increase in price, so an increase in the price of apples is going to change the welfare of our consumer and how happy consumer Kara is going to be. We could also think about the application of taxes to our model where our two goods are leisure and consumption is purchased from the earnings from work. If we add taxes, that changes the trade-off between consumption and leisure, and it changes the decision maker, the decisions that our workers make. Those very political applications. So if you're interested in politics and the study of economic policy, economics is extremely helpful. As we move through the course, we're going to introduce our firm side. We're going to put supply and demand in equilibrium. We're going to talk about perfectly competitive markets. And then we are going to relax these assumptions and talk about markets that are monopolized and the loss of social welfare there. We're going to talk about when our markets fail, when we have externalities associated with the production or the consumption of goods. And then we'll get into what externalities are later. And then we'll also talk about the cases of public goods and common resources where our markets fail to produce the optimal quantity. I hope that you found this live review session helpful. I apologize for it not being available earlier, and best of luck on the exam. This will conclude our live session for today.